Hello everyone, this presentation is hosted by Group66. Now our topic is Zero Knowledge Proof. This is the outline of our presentation, and we will introduce each part by different members. Well, nowadays, people have to use many applications by registering with personal information, but it would leave a serious problem, which is the privacy leakage. So how can we protect our data? Is there a way to provide the data without revealing the data itself? Yes, there is an emerging technology called zero knowledge proof or protocol. So what is it? Simply regarding the definition, in cryptography, a zero knowledge proof or protocol is a method by which one party can prove to another party that it knows the secret without revealing the secret itself. Let's take Alibaba's cave as an example to demonstrate this. Alibaba's cave is a ring cave separated by a secret door, and there is only one entrance as well as exit. Now Alice knows the code of the secret door and she wants to prove it to Bob. So firstly, Alice can choose one path to randomly to enter the cave. And then Bob also can choose one path and let Alice come out through it. Then if Alice can come out through the right path, Bob will know that Alice has the code. But there is a lucky that Bob and Alice had chosen the same path, so we have to repeat this process many times. So finally, Bob will only know the fact that Alice has the code, but Bob doesn't know what the code is. This is the zero knowledge proof. In addition, zero knowledge proof must contain at least two parties. One is the prover and another is the verifier. In this case, Alice has the code, so she is the prover and Bob is the verifier. Also, zero knowledge proof has three properties. First is completeness, which means if Alice and Bob are trusted parties, the process of verification will finish successfully. Soundness means that no one can pretend to be Alice to prove the fact to Bob. Zero knowledge is that Bob can only know the fact that Alice has the code, but he doesn't know what the code is.
Thanks, Hongju introduced that. What is zero knowledge proof? So the main idea behind this protocol is to prove a knowledge without disclosing the relevant information. In order to understand how it works, let me first introduce challenge response of zero knowledge proof. Also, there are two types of zero knowledge proof, interactive and non-interactive. Interactive zero knowledge proof require interaction between the prover and the verifier. It requires interactive inputs from the verifier, which is usually in the form of one or more challenges, such that the response from the prover will convince the verifier if and only if the statement is true. For example, Alice wants to claim knowledge to Bob. Alice first sends a proof request to Bob. Bob sends a challenge and asks Alice to calculate and send the answer back. According to the answer, Bob can verify if Alice's statement is true or not. Next, I will introduce discrete log of zero knowledge proof. It is used to prove someone that I know discrete log value x of equation b equals to a power of x mod p, without revealing the value x. The value x could be secret password. There is an example. Alice claims that she has the secret key x for the above equation. She needs to prove it to Bob. She keeps x secret and only answers questions from Bob. Alice first generates a random r and calculates a power of r mod p and sends h to Bob. And Bob will generate a random b and send it to Alice and ask Alice to calculate R plus bx mod p minus 1 equals to x. From Alice's answer, S, Bob needs to verify if left equation is equal to right equation. If this equation is equal, Bob can conclude that Alice's statement is true. Otherwise, Alice is lying. This challenge response example shows zero-knowledge proof are only a statistic guarantee something could be true. There is small possibility the cheater proof could be convinced verify of a false statement. The proof process requires a lot of effort. We want to prove it to more than one people. Next, my partner will introduce another schema of zero-knowledge proof.
Short Shamir is one of the major zero-knowledge authentication schemes. It's also the earliest and most basic one. As shown in this figure, both Peggy and Victor know the public key V and N, and the private key of Peggy is S. The process of short Shamir has 4 steps. Firstly, Peggy chooses R, which ranges from 0 to n-1, then send R square modulo n to Victor. Secondly, Victor chooses 0 or 1 randomly, then send this value to Peggy, which called challenge. Moreover, according to the challenge received from Victor, Peggy will send Y. This is called response, and is computed by R multiple S to the power of V modulo N. Finally, Victor will verify Y square, and no information is disclosed during the validation process. So what are the applications of zero-knowledge proof? Traditional digital currency like Bitcoin makes all the transactions public, and everyone could see others' balance. However, Zcash uses non-interactive zero-knowledge proof to hide all the information. And this technology is called ZK-SNARKs, which stands for Zero-Knowledge Succinct Non-Interactive Argument of Knowledge. For blockchains, zero-knowledge proofs ensure the transaction is valid with hiding other details. Aside from cryptocurrencies, traditional banks could also make use of this technology. The Dutch bank ING built a variation of ZKP called zero-knowledge range proof. This concept was designed to prove that the target number is within a given range without revealing any actual number. This technology could be used to verify if your salary is sufficient to get a loan without actually revealing how much you earn. This technology could help people to protect their privacy. And now my partner will conclude our presentation.
In this part, I will draw a conclusion regarding advantages and limitations of ZKP. For the advantages, ZKP will not decrease the security, because there is no useful information related to the secret transmitted between the two parties. Second is confidentiality, as we introduced before. The verifier only knows the fact that the prover knows the secret, which means that no one can access the secret except the prover. And for the limitations, interactive ZKP needs a lot of data transmissions between the two parties, so it also costs a lot of time. And for the transferability, interactive ZKP cannot prove the fact to many verifiers at the same time, but the non-interactive ZKP can do this, but each verifier needs a lot of computations to verify the message by itself. So zero-knowledge proof still needs further improvement. And this is our reference page. Thank you for watching. Any questions so far?